Hello everyone. Today we are going to solve question number 234, Palindrome Linked List. Given the head of a single linked list, return true if it is a palindrome or false otherwise. Okay. In this video, we are going to discuss two methods to solve this question. In the first method, we are going to use array, and second method, we are going to divide this list and then we are going to compare it. Okay. So let's see uh, first the goal of this question. The goal of this question is going to be check whether this list is palindrome or not. Okay. So first of all, you should know what a palindrome number is. Basically, a palindrome number is a number if we read it from left hand side or right hand side, it is going to be same. Okay. For example, here is 1221. So if you read from this side or you read from this side, it's going to be same number. Okay. Same way these are all the other example 09090. Okay. So these are some examples for palindrome number. Let's see the first method to solve this question. The first method is going to be that the first thing that comes in our mind is accessing the elements in a linked list in reverse order is not possible. Okay. Hence, the first solution should be storing all the elements of palindrome linked list inside an array and then checking if this array is a palindrome or not. Okay. That's the very simple solution that we can think at very basic level. Okay. Hence, what we are going to do in this method is going to be we are going to convert this list into this array, and then we are going to check for this array. If this array is going to be palindrome, then our list is also palindrome. Okay. So the tasks are going to be store this linked list inside array, check palindrome, and return answer. Okay. It's very simple. Let's code this one directly. Okay. So first we'll need a vector to store array, a vector to store list elements. So vector int AR, then we have to traverse over this list. Okay, so list node star temp is equal to head. Now while temp, okay, while temp, or you can say while temp is not equal to null, same thing. Okay, in that case, what you're going to do is you're going to store elements inside array. So arr dot push back temp's value, not the node, but only its value. Okay, and then we are going to move temp. So temp is equal to temps next. Okay, after these we have an array that stores all the elements of our list. Okay, now we just have to check palindrome. So I'm going to write a function that's going to check palindrome from this, and then I'm directly going to return answer from this one. Okay, and this is another function for the second method. I'll write another function here. So this is going to be bool check palindrome vector int AR. Okay. Now what we need is we'll need two pointers. So int L is equal to 0, int R equal to ARR dot size -1, and we just have to compare them. Okay. So while L is less than R, if ARR of L is not equal to ARR of R, that case return false, else move L plus plus, R minus minus, and in the end return true. Okay, so this is a simple code to check if an array is palindrome or not. Okay, using this condition, if the number of elements are odd, most probably this is going to leave one element, and since one element is itself it's a palindrome, so it's going to pass on. Okay, so this is for check palindrome. Let's close this. Okay, so this is going to check us and this is going to return us. Okay, so let's run this. Okay, let's submit this. So we have solved this question using uh, an extra space. I will say that we have an O of n space complexity for this method. The second method, this second method is going to take O of one space complexity. Okay, so let's see the second method. So now we're going to see the second method to solve this question, which is going to be divide and compare. Okay, I named it as divide and compare. Let's see what this method says. Okay, basically, the core idea behind this method is going to be I'll divide this list into two parts. Okay, then I'm going to reverse the second part, and then I'm going to check for palindrome. Okay, so you can see in your mind that here, let's say you had this list. Okay, you had this list, you split it from middle and you reverse this part, so you'll have an identical list to this section. Okay, and hence after comparing these two lists, after converting this one, we'll have a final answer. Okay, so this is going to be a method. The task to follow this method is going to be traverse to reach the middle and split it into two. You can use any method to reach the middle part. You may use get length to count the number of elements inside the list, and then you can split it, or you can use a slow and fast pointer to reach middle point. Okay. Second thing is going to be reverse the second half of the linked list. Okay. So basically, the second half is like this, from 3 to 1. But I have to reverse them so that I can check 1, 2 with 1, 2. Okay. So 1 is going to be checked with 1. Hence, I have to reverse this second part. Okay. Third thing is going to be check for palindrome among these two lists, and then we are going to return. Okay. And one thing that I should mention is that you don't have to stress over the odd case and the even case. I have taken the hard case where this is an odd case. For the even case, you can see here, this is an even case where the number of nodes are even. In that case, the split is automatically between these two and these two. Hence, there's no extra case. But in the second case, where the number of elements are odd, in that case, this middle element can be can stay either with the first half or the second half. It clearly does not matter. Okay, because once one of these lists are going to end, in that case we are going to exit the loop. Okay, so this one, a single element will be counted as palindrome itself. Okay, so let's see the visualization part. You can see first we will travel to reach the middle of the linked list. You can use previous current. We can use slow and fast pointer also. Okay. Next, we'll have this list separated from this first part. We'll keep first half separate. Now we'll have second half with head 2. We are going to reverse this, so we'll reach this list where we have 1 2 3, and this list have 1 2. So for head and head 2, we are going to compare them. Okay, compare these. So head, we are going to move head, and then this one is left because, okay, this is going to be sorted by itself. Okay, so that should be the method. Let's code this one. Okay, so basically we'll need I'll use slow and fast pointer. Okay, so list node star slow is equal to head. List node star fast is equal to head. Okay, and one thing that you can notice is in this case, to uh, like cut off this link, what we need is a previous. Okay, so I'm going to keep a previous for uh, this list, because since we have to cut off this list, our slow is going to reach to this current. The slow is not going to reach this. Slow is going to reach this current. So as okay, so let's see this one. List node star previous is equal to null pointer. Okay. Next we'll traverse. So while fast and fast next. Okay. This is a very simple method to write fast and slow pointers. This is very common. Okay. This is very common. You can directly remember this. Okay. Next we'll move fast first. So fast is equal to fast next next. Okay, I'm moving 2 steps directly, and I'll point previous to slow so that I can store it, and I'll move slow. So slow is equal to slows next. Okay, so after these three we have pretty much this we have reached this condition, okay, where current is equal to slow and previous is previous. Okay, we have reached this condition. This After this condition, we can just do previous next is equal to null pointer. Okay, so we have disconnected the list, and my current head, or you can say current, stays at slow. So I have to reverse this slow. Okay, now I was hiding this function from you guys. This is the function to reverse list. Okay, a very basic function. What it receives a head. After receiving a head, we'll have a current and previous, which are going to help us reverse this list. Okay, the reversal part is very simple. We'll have a previous here, a current here. Okay, current is going to point to this. We'll store this. Current is going to point to this null, and or previous is going to move ahead. Okay, so it's very simple. I've also discussed this method in my previous videos. Okay, so this is a simple loop to reverse this list. Okay, we'll not go deep into this one. Okay, so simply I'll have a list node star new head. You can say head 2 is equal to what can I say, reverse list and slow. Okay, so this is going to return me a reverse list with uh, a new head. Okay, and since we have already modified the original list, now I'm directly going to use head as traversal. So while head and head 2. Okay, so this condition means that if this list and this list, either of this list is now empty, in that case we can directly exit. Okay, so the check case for this one is going to be if head's value is not equal to head 2's value. Okay, let me give some space for better reading. Okay, then in that case we can directly return false. Otherwise, in any either case, we have to move head. So head is equal to heads next, and head 2 is equal to heads next. Head 2's next. Okay. Okay. In the end, we can directly return true, because if we have cleared this while loop, that means this is a palindromic list. Okay. So this should be the simple code to solve this question. Let's run this. I don't think there's an issue here. Okay, we are accessing something out of bound. Defined behavior. Okay, this is case for a head or the. There's only one element inside the list. Okay, so we have to handle this case separately. Okay, so for one element, what we are going to do is if heads next is not equal to null. Oh, sorry, is equal to null. Equal null. In that case, you can directly return head because a single element is palindromic itself. Return true. Okay, let's run this. Okay, let's submit this. I think LeetCode is bugged. Okay, so that's it for the video. We have solved this question using two methods. This second method is going to take a time complexity of n and space complexity of 1. Okay, because we have not created any array or stack or something like that. Okay, so that's it for video. Thank you. Bye.